Forensic entomology is a relatively new science, which helps guide the time of death of the corpse and in some cases of death. In this science is studied insects related to decomposition of the bodies and taking into account the biological cycles. Biological cycles we provided very close to the time a corpse has been dead, and the study of IPM postmortem interval we can help by identify how the person killed. Toxicological analysis is possible and even molecular stomach content of insects found at the scene of the crime. This is why forensic entomology is an important tool in crime investigation cases.
Nature, so they occur all around us all the time, even if we don't see them, and therefore they're very likely to be involved in a crime scene, whether just accidentally or actually because they have moved there in response to some element of the crime scene. Looking at the body itself, it would be a pathologist who would look at the changes in the body and try to determine from the body what the post-mortem interval is. But as an entomologist, I can help the pathologist by looking not at the body but at the insects that are feeding on and around the body. More precisely, we're determining a minimum post-mortem interval. That's basically the period that the first insects found the body after death. Ordinarily, in the summer months in the UK, with the body outdoors, it will be colonised by insects within 12 to 24 hours. At the crime scene, the main thing is recovery of evidence, and I'll do that at the scene and then go back to the post-mortem and carry on there if necessary. We're interested not just on the insects on the body, but on insects that have been feeding on the body and may already have dispersed away, because it makes good sense for these insects, once they finish feeding, not to hang around on the body because some other scavenger may come and consume them as well as the body. So they tend to disperse away. The gold standard forensic indicators are blowflies, and these are the ones that come in first immediately after the body's dead and starts to decompose. They have an incredible sense of smell and will arrive very, very quickly after death. The female fly will lay between 150 to 200 eggs on the suitable substrate, and a human body is absolutely ideal for that. Within about 24 hours in the UK summer, those eggs will hatch, and they'll hatch into first stage larvae, and these larvae are tiny, 1.5 millimeters long. Those larvae though are very hungry. They'll crawl into the recesses of the body and start feeding. Within 24 hours they themselves molt into the second stage maggot, and then about another 24 hours later those will molt into the final third stage maggot, and that will feed for about 3 or 4 days. When it's finished feeding, it disperses away from the body and looks for somewhere to pupate, usually somewhere dark. It begins to harden itself and darken itself until it forms a rugby ball shaped puparium, and inside that pupa the larval tissues are reassembled through metamorphosis into an adult fly. It's a quite remarkable process that amazes me even today. After about 10 days in the UK summer, the adult fly is now ready to emerge, and so the life cycle continues. When blowflies respond to the odours of decomposition, they tend to navigate their way upwind through the odour plume until they arrive at the scene. They'll then use their visual cues to land on the body and to move around and look for the most suitable egg-laying site. Eggs are very susceptible to desiccation, so they tend to choose areas where the humidity is highest, so that tends to be the body orifices, the eyes, the nose, the mouth, and the genital anal orifices if those are exposed. And of course the humidity is maintained in those environments, but it also affords the larvae the opportunity to crawl into the body and feed on the internal tissues, which are less well protected from the insect enzyme activity than the hard, tough outer skin that normally covers our body is. So the focus of blowfly colonisation tends to be on the head orifices. In this image just coming up here, we have a stillborn piglet. All you can see at the moment is the hotspot, and you can see a fly that's just landed on it there. Surprisingly, although they're cold-blooded, flies themselves generate quite a bit of heat through their flight activity and muscle activity. The pig outline now is formed because we've adjusted the temperature range, and you can see there's a couple of flies moving around there. We know that they're not the first flies to have found this piglet because that hot spot there is in fact where there's already a small maggot mass developing. And what you can do actually is if you can take a series of images over a time scale from, in this case it was from day 1 to 14, so a couple of weeks period. In the first 6 days or so, not a lot's happening because it takes a while for these first flies that have come in on day 1 to lay their eggs for the eggs to hatch. This was during a winter period. But on day 6 the temperature starts to go up in the mouth of the pig, and then over successive days that temperature hot spot moves down through the body of the piglet as it's being consumed basically by a larval mass which is just rolling from the front end to the back end of the piglet. And then after 2 weeks the piglet is now completely cold and empty. All of the maggots have finished feeding and they've moved away. So one of the accessibility issues we've been exploring at the museum just in the last few months is the impact of putting a body in a suitcase. Is it possible for flies to find a body in a suitcase? And if so, how quickly? Well, we found that using pig heads as surrogate bodies from a butcher shop, just pop them into a normal carry-on suitcase, and they delay the arrival of the flies by 1 to 3 days or more, depending on the temperature. However, the flies will arrive at the suitcase and they know that there's a body in there, and they will actually oviposit through the zip, which most suitcases are sealed with these days. The eggs will be laid into the suitcase, and in fact if they're just scattered around the zip, the larvae themselves when they hatch can crawl and enter into the suitcase. So even hiding a body in a suitcase won't stop flies finding it, and once they've found it they'll feed on the body in there, and in fact they will then try to actually exit the suitcase as well, and they can do this often through the holes in the frame where the wheels of the suitcase are found. So there's a whole range of factors out there in the environment and even in the human factors of the environment that can complicate the situation and make it a real challenge for a forensic entomologist to engage in any investigation.